Yeah, so I guess we start and good afternoon, good morning, good evening, everyone, whichever part of your world you are in right now. Welcome to this episode two. Um, and our focus has been enterprise blockchains, and it will continue to remain that way. In the first episode, we covered, the cost bits of enterprise blockchain, the ownership cost. How do you do blockchain and yet maintain and manage your cost, and what it takes in terms of cost. And then, in parallel, while exploring cost, we also could explore different aspects of or different parameters which impacted the cost for any use case which could be implemented on blockchain. Today, we will be touching upon a different topic. Of course, it's a topic which is vital when you would want to do something more than just caring about blockchain, and in the enterprise space when you design a solution. So the design of a solution, its construct, its core, its architecture, different things to consider, what to do, what not to do, and what is important, what are the key things. And in fact, in the end, we would be covering a very special slide which would talk about, if you would want to implement something within an organization using blockchain, how would you take that path? It's quite a path, I'm telling you. So I'll share my slides. We'll start running through the exciting topics. And for the Q&A, I've got inputs already that we should open up chat or the Q&A box, so that would remain open. But I think we'll try to not make it the last session where we were running short on time and it went on and on beyond an hour. We'll give enough time to the Q&A stuff. So I'll simply put up my slides. I'll maybe turn off my video so that you can focus more on the slides. And here we go. So this is the topic of the day, and people who joined in, I'll repeat again that last time we covered cost of doing blockchain, cost of ownership of a blockchain solution in enterprises, and today our focus would be on how do you design a perfect enterprise blockchain solution, what aspects to look after, what things to care for, what are the key factors you would be indulged in, how do you construct it all together in one. And then in the end, we would also be covering that, what is the journey, the roadmap of one doing an enterprise solution into their organizations, taking the approach until the very end. And to start with, of course, this has been there since the beginning of blockchain. And we all know that, that it's not meant to do everything. There are things which you might not apply blockchain to. So we have to be wise, we have to be careful, and we have to understand it because it's at times very complicated if you would apply it to certain use cases, and at the same time very complex. So it's both, and it requires a proper path of decision making to attempt a blockchain implementation within an organization, specifically to enterprise grade solutions. So we have to be very careful while attempting it. We'll have to generate enough awareness and education around us and within us so that we'll know. We'll go through certain decision making trees as well, so that we ourselves are clear in terms of how do we and when do we do blockchain solutions or not, where does it fit the best, and if it fits, what things are to be catered to. But usually, when people say that do a blockchain solution, what they talk about is, what type you want to pick, a public blockchain, a private blockchain. And nowadays there is, another third segment of blockchains, which is available, which, people call hybrid blockchains. So, just for the definition's sake, I know that you are all well versed about with blockchains. You know what public blockchains, private blockchains are, but still, for the sake of the construct of the session, I'll talk about public blockchain. So, public blockchains are, what we have heard in the spellings of Ethereum and Bitcoin, Polygon, Avalanche, Algorand, Polkadot. These are the examples of public blockchains, and their primary nature is that everybody has got equal rights, equal participation, and equal access to whatever happens on a chain. So, for example, anybody can come in, run a node without nobody governing his access or her access in the sense that is he allowed or not. And then once he's connected to the network, he's got access to the ledgers. He's able to sync all the blocks since the beginning of time. So there are no restrictions, no discriminations, no access control, no specific permissioning in public ledgers. And they once were and still are the most pure form of decentralization. Of course, there is a big debate about decentralization. We've got the series going on. We'll definitely touch upon those topics. But yes, public blockchains are primarily equal rights for everyone and open ledgers. And then there is private blockchain, where you can apply certain permissioning. You can limit it to a group of consortium owners or stakeholders, beyond which things won't go. Your ledger would remain between these people. And then even in some technologies, some specific protocols, they also allow you to limit or define permissioning in different groups in different ways. And then there are hybrid blockchains. This is pretty much this is something very new. You can say that the third generation of blockchain is looking into it, where you can amalgamate both public and private in a way that it fits the use case. We'll explore it further in a better way. But when you start thinking about doing something into blockchain in an enterprise ecosystem, of course your focus would be on private blockchains. But then there are interesting things happening, and we'll talk about them in a while too. But yes, this is how you start. And you start by picking up a type of chain you would want to have for your use case. And then so these two steps, I'm telling you what people usually do. I'm not saying they're right or wrong yet. But I advocated myself a while ago that one should be going through if blockchain is a fit or not. But then this is what happens when you start doing blockchain, thinking that it would work for you. Then you come after the choice of a private chain, you come in and decide, oh, which framework should I choose? Should I choose Hyperledger Fabric? Should I choose R3 Corda, or maybe Cordite, or maybe I choose private subnet? So I think if you would focus on private subnets, you would find it interesting. What is private subnet or private side chain? So this is something which is coming out to be true in third generation of blockchains, where you got a core chain, a relay chain, a beacon chain, a main chain. I'm just quoting these out of some of the examples which exist today. So when I said relay chain, I meant Polkadot relay chain. When I said beacon chain, I meant Ethereum 2.0 beacon chain. When I said primary network, I meant Avalanche primary network. And then in Avalanche, you've got subnets. In Polkadot, you've got parachains. In Ethereum, you got shard chains. So they have defined a new set of side chains, or you can say sub chains, or you can say parachains, which are capable of allowing us to define a very specific token economics, very specific permissioning. Even we can go private, being a sub chain or parachain, while still being part of the public chain or a permissionless chain. So this is an interesting bit, how private subnets or private side chains or private parachains would come in play, and how they would benefit us in different architectures of our, or different use cases of ours. But this is interesting. One interesting fact about, I would say the most interesting fact about these private subnet side chains, parachains, is that not only they allow you to define your own token economics, but then you're not programming a chain yourself. But when we say that we can have our own ledger, we can have our own token economics, we can have our own native token, and yet stay private or permissioned, while still having the option of being permissionless, means that without creating an L1 protocol, you are having all the capabilities which a layer 1 protocol has, while you may act as a layer 2, or maybe not layer 2, layer 2 is not the right word, a side chain to that primary chain, and have all the capabilities of a full blockchain solution. So it would come out handy in some cases, and you may reconnect it with hybrid in some way or other. But then there are a lot of different things like interoperability, which is different in hybrid chains and in side chains, or these kind of ecosystems. We'll talk about them. But then picking up a chain, then picking up a specific protocol, this has been the obvious thing. But what we missed out on is the primary topic we started with. Do we really need a chain or a blockchain solution? So let's quickly go through a decision tree, which will help us, decide if we need a chain or not. Because this is where your journey must start. Instead of directly jumping into the chain or blockchains or Web3 world, you should start thinking which use case of yours is going to be the target, and if that use case requires implementation of blockchain or not. So of course, the first question would be this. This is a limited tree. I could not draw the proper one because it was going beyond the slides. Initially, you can have some high-level questions, then there are more questions, and then there are more categories and questions further. But this is limited enough or good enough for you to start. So first question, let's focus there. It says, do you need a shared consistent data store? Now, shared consistent data store, what does it really mean? It means that we should have consistency in the data. We should have all the integrity aspects of it handled, and it is still to be shared. It is yet to be. It is still shared. So do we need something like that? If no, then I think blockchain, which primarily is to provide you a historical provenance of whatever happened in around and about your data, and you don't require that with your data, then it may not be a right use case for you. You can use any centralized database for this. But in case you have a requirement of consistency, integrity, provenance in your data store, then the next question would be that does more than one entity need to contribute data? Because if not more than one entity is contributing, in one way, the control on data's existence or generation still depends upon one party. And still, there may not be trust issues with the data. So if no, and your data comes from a single entity, then it may not be the right use case for you too. Of course, there are further segregations and further questions which can be asked here, but at a high level, if the consistency is not a requirement, it need not to be shared, and only one party is generating the data or contributing it, you might not want to implement blockchain. It may be an overkill. But in case you've got these two requirements there with multi-parties coming in to contribute the data, then your next question would be, do you really need to preserve records as it is? Now, most people talk about blockchain as that it's tamper-proof. So this is, nothing but a synonym to that. People say that blockchain over blockchain you cannot delete the data. That literally is not true. You can delete, but then the record of that who deleted and when deleted will still persist. So of course, these kind of operations on data would be considered that would you want to preserve data as it is. So any time at any point of time, the state of data would be preserved as it is. It's only modified in future in different ways, but then all the past states would remain as it is, and they'll exist until you actually delete the blockchain. And deleting blockchain means deleting it from the every node possible across the globe or wherever it is running. So if you require data to be contributed by multiple parties, you would require it to have certain characteristics in it. You would require it to be shared, and you would require it to be preserved in a way that you can have a complete provenance available on every operation transaction happened around it with the data itself. In all past states of it, you would definitely require blockchain. But then there are multiple scenarios here. So you cannot manipulate the data in the sense that you can delete the historical existence of it, but of course you can update it and modify it. So the next question would be the entities which are participating and has got right access. Do they have trust issues between them? Do they question a lot that who's writing what and when and who changed it? So it's about the control on the ledger of the data store. So if there is a lack of trust, if there is uncertainty on control between multiple parties, and they question each other on that, then yes, you would require a blockchain based solution. And then the next question should be that it does it have to be tamper proof? Usually, the properties we talked through, if you would have to do a use case, of course it has to be tamper proof. But again, going back to the same definition, tamper proof does not mean that you cannot change the values in your ledger. Most people ask those questions, and most of you are already aware of it, but I'm repeating it for the group's understanding, that you can delete things, you can update things, but you cannot delete the existence of that something has been deleted. So whatever existed in the past will remain as it is. Something has been deleted from the application perspective. We'll talk about this in a bit, that how a deletion is not a deletion and yet a deletion. So we'll talk about it in a bit. Now, coming back to the topic, so if multiple parties are struggling about the control on the data store, and you want all sort of proof of operations on the data, it's a solid use case, and blockchain may come in really handy. But in the cases where they're not struggling with the data control access, so it means there are no trust issues between them, because they are the contributing parties and they don't have trust issues. It's like a small group of people which are like departments within the same organization, governed by the same management or board. They may not have to implement blockchain because they may not be struggling between themselves. But in some organizations, this may well be a use case. So this is a high level tree through which you can run your use case, and then see if that fits for a implementation or not. There are many decision trees available out there nowadays. Some I would recommend that you can go and study some Deloitte decision trees. They are more extensive in the sense that they have given it a better shape, in the sense that they're not general. They target certain industries as well. This is a very generic one, which focused most on the data aspect of it, the trust and transparency and provenance of it, the tamper-proof nature of it, and between multiple parties, of course. But then there are industry-specific decision trees we can draw and build. So moving forward, imagining we require a blockchain solution. Imagining that the blockchain solution would be implemented. Now, how does it all start? We defined the type of blockchains which are out there. Now we would want to decide which of those chains we would want to pick. So again, for most enterprise use cases, permissioned ledgers fit a lot. Private blockchains fit a lot because they give them a sense of control. They give them a sense of distribution. They give them a sense of decentralization, yet a limited group, a sense of privacy, security over the transactions, over the ledger. So this is why most of the enterprises and to be very specific, banks and fintech segment companies or enterprises would look up to private chains. And on the private chains, we got so many potential frameworks. I talked about Hyperledger framework, I talked about R3 Coda framework, and I talked about the private sidechain concept as well. But there are many other as well, which are coming up. So while picking a chain, we must decide upon certain things. And why deciding those things makes a lot of sense in terms of how you would end up in the end, and why on-chain, off-chain, and batching is related to that. So if we are to use a protocol, but then our use case is data heavy, first we need to identify that if it is data heavy or not. I'll give some examples. So if we are building a supply chain solution, or maybe a trade finance solution, then we are dealing with a lot of documentations, and in some way you can say digital records or digital documents to be stored. For example, the invoices, the purchase orders, the goods receipt notifications, the letter of credits, and a lot. And when that is the case, blockchain has been criticized. It has been criticized. It is still criticized that it is not meant to store documents on top of it. It means we're saying on-chain. So I'm in one way defining and explaining at the same time what on-chain is, and how do you decide if something is to be kept on chain or not. So if your requirement, your use case is data, heavy, then of course you cannot store everything on the blockchain. So which is the on-chain scenario. Now, this means we have to define different data sets we have available for a use case, including including everything which comes in the flow from the very beginning of the cycle of the business flow or business process to the very end. And the data which is important, which you would want to keep the provenance of, which you would want to be tamper proof, which you would want to be, or which you would want to become the single source of truth among everything, should be kept on chain, which is usually questioned, which is usually targeted, and which is the cause of dispute. Those things are to be kept on chain. And then when we say off chain, which means, of course, it's something which we cannot store on chain. It's heavy. It would make the chain slow. It would reduce its lifespan. Then it means we might end up having several choices, because usually off chain, the very basic version of is the traditional databases like Postgres, MySQL, Mongo, Cassandra, and a lot many others. But then what is the correlation between the on-chain and the off-chain? How do you define that rule? Because on-chain, everything is driven by the validity rules, and you've got a proof of everything, and you are very certain that the purpose is fulfilled there. So you can every time, any day, any moment prove that, oh, this is what happened with all the on-chain data. But then how do you deal with off-chain data? So for example, if there is a transaction, inward, outward transaction in a supply chain, operation, where a shipment is moving out of a warehouse, reaching towards another maybe distributor, then at what time it left the warehouse, or what units and batch it was carrying, those things, for example, the batch ID, the SKU details, or maybe the warehouse details, the GPS locations, or something similar, can be part of the on-chain data sets. But then there could be some documentation alongside with it. For example, some sort of dispatch note, some sort of maybe invoice or similar. Then those things cannot be stored on chain. Now you would want a system, but if this system, for example, there are two organizations, A and B in this supply chain use case. A dispatched something towards B with some sort of gate pass or thing here, or maybe some dispatch note here with some details registered on chain about the goods it's carrying, some batch ID and other stuff. But then the rest of the data, they stored it onto their own off-chain databases or storage units. Now, how on the other side, even the other side, which is B, being a participant of this blockchain network as another enterprise in the same supply chain consortium, would have access to this off-chain data? That's question number one. Second, if they would have access, then why do they trust this data? So going back to question number one, usually, these enterprises, they work in silos. They'll never allow them to touch each other's data. Why they're coming onto a blockchain network? Because they wanted trust, but then that trust is limited to certain aspects of data, and that would be the only data which they'll allow in the ledger, ran by both of them in their own nodes, being part of the same network. So in this case, how the off-chain data gets to the other party, gets verified and addressed, while once the shipment reaches the other side, they may have their own documentation around it, the entry note and this and that and all, or maybe the goods receipt notification or something similar, and then they would generate it onto their own systems in their own document ways, maybe PDF or something. So usually what this tells us is that building a blockchain solution for an enterprise is not one organization task. It's not one enterprise task. They have to come together. They have to architect it together. They'll have to understand the nuances of the data, its existence, when it is in flight, when it is at rest. When I say at rest means, it's stored somewhere. And what is to be kept on chain, what is to be kept off chain. And once this is decided, we have to go beyond and discuss that how it is to be accessed. Now, this is a two-step process. One step is the business workflow, business process decision making, and then other is the technology architecture level decision making. So if you're very, if these enterprises are through with business process flow, workflow, and data flow level of decision making, that this is what they are going to be shared, this is when they would require access, and this way the access would be required, and so on, then in those cases, the job then comes down to the technology teams, where they would have to define such an architecture which consists of both on-chain and off-chain capabilities, which would allow them to interact and verify the on-chain data and transactions and records, as well as off-chain data and its existence and its validity, in the sense that it has not been tampered. I'll take a pause here before going further and all, but I would, really appreciate if you guys can share, the protocols, if you have been using within your organization, like if you have been using R3 Coda, Fabric, or maybe any other, protocol to build any of, the enterprise blockchain use cases until date, and have you been using on-chain or off-chain already? So if any of you have used it already, just put it in the chat. We might pick it up during the conversation and utilize it to discuss further. So while you would type, I'll simply talk about batching. This is one interesting aspect while designing a solution, because on-chain, off-chain, this is pretty clear. But then enterprise blockchains, of course, they are praised for their throughputs, but then at times you do not want to be an overkill while building a solution. So you might want to batch your transactions in the sense that you are keeping the record of multiple transactions into one transaction and then writing it on the chain. And every time you would want the proof of any transaction which took place, you would look at this transaction where you have batched everything and written on the chain. So this is how it is usually. And I've got a question in the queue, and I think let's take it up right now. The question is from an anonymous attendee. It would be great to have your name and to know you as well. The question is that I'm interested towards knowing how deletion is still able to hold the history. I think it will be covered in later stage. So I think let's reveal the fact here itself. When I said deletion, usually when people talk about deletion and update and modification of the record, they're mostly coming out of the Web 2.0 world, and that's how we all have understood these CRUD operations. Create record, delete record, update record, and modify record. So these operations, what they are doing is they're mostly these operations are mostly application facing. So for example, I have a ledger saying the balance of this vendor or the payment due of this vendor is like XYZ amount. Now in case there is a mistake in the number, or maybe there are two entries which exist someday and they're displayed on the application. It can be a very simple application like Tele. If there are duplicate entries done someday, now I would want to remove one entry. It's pretty simple. Like it's like if this is an employee list and there are two entries, you would say, oh, this is a duplicate entry, let's remove it. Now the question is, where are you removing it from? Because if once it existed on chain, you're not removing it from the chain. You're simply changing the state of this data to a new state. Where earlier there were two rows, now there is only one row, but both the rows will always exist on the chain. It is just the application which would not show the other one because it has been deleted. So the ledger, there is a history where two rows existed, and they would always exist on that day when they were actually registered on the chain as data. But then in the newer sets, you can register newer sets onto the chain. So it's like, if there is a variable A, I have got a value stored in it, I can update it n number of times. And every time I'll update it, I'll end up creating a record in the ledger or on the ledger. And that means that the application facing value would have changed. it might have felt like a deletion, but at the back, it actually happened differently. So I think that I believe that that answers your question in a good way. So we got one input coming in the Q&A already that talks about that they have used Hyperledger Fabric and on-chain and off-chain methodologies both for a land registration ecosystem in their organization. So this tells us that on-chain and off-chain, it's not new, and how it helps different use cases when we have to go around architecting or designing the construct of digital documentation and important data provenance. So we plan both in this way. But then in off-chain and on-chain, there is a very important set which is required. And that is, how do you prove that the off-chain data exists and it was never touched? So for example, again, going back to the same supply chain example. So for example, we written the batch number, the time, and the GPS coordinates of, a specific shipment into the ledger on chain. And there is some documentation against it, like, an invoice or maybe some goods receipt notification into, some data store. And there is a lot of data. Rest of the data we stored onto a MySQL database or Postgres database. Now, that data, which we have stored on MySQL, is written someday, and it has to exist against a transaction done on chain. It just cannot exist without a transaction done on chain. So every time I'm writing a data on chain and on off chain, there is a relationship between them which I have to develop, or which I have to design, I would say. So when I'm writing this record on chain that, oh, this batch of shipment has actually gone out from this warehouse on this date, this time, but then there are a lot of other details, a lot of other metadata attached to it. I would then write that metadata into the MySQL, Postgres, or other off-chain data store, but with one transaction ID that says that, this is against this transaction on chain. Now, so in one way we are saying that there is atomicity we're following here, that every time something happens there, it would reflect here. But then what happens, so this is just a simple association. This is not us defining or describing any validity of it. So what if I edit the MySQL database or Postgres database directly? I would also keep a hash of all the data in the MySQL, row by row maybe, or maybe column by column if required, into the ledger while doing the transaction. So that would give me a reverse traceability and validation mechanism as well, that anytime if I would want to verify the data off chain, I would simply take the hash of it and take the same transaction against which it is written, and from the transaction, I'll take the hash of it, I'll match, it won't match means the data is not valid anymore. So this is this is how it is done, and there is more to it. There are Oracle services which help you define the atomicity and the transaction flows. How do you do it this way? And sometimes blockchain transactions take time. Not in the private blockchains, it happens like that, but it still takes time. So you enter a data record in the off-chain DB, and then in future you'll have to update, for example, a status column which says in progress processing or done or completed. Then you would again follow the same flow, and you would still update the record on the database outside. And Amit is asking that the importance of storing sensitive and important data document on chain, such as invoices, etc. But there is also IPFS and Filecoin, etc. Can you discuss if you have any experience of storing data on IPFS, Filecoin? And he's asking, isn't IPFS immutable and has all the advantages of decentralized storage, but also you don't have to store on chain? Yeah, so I agree with Amit. IPFS is there, and we have a strong support for IPFS too, and we have indulged ourselves in several many such. I was part of such implementations. But if you focus on our description again of off-chain data, we were not just talking about files. We were also talking about a lot of metadata where you would require it later for reporting purposes, some business intelligence, some other CRM related solutions. So in those cases, you would require extensive reporting. And IPFS, it's a pure file system. You can store files, but it's unlike MySQL, Postgres, or MongoDB, where you can run rich queries and do a lot of this and that combination of data and reporting. So this is why you would require on-chain data, which is your blockchain ledger, depends upon which protocol are you using. And then there is off-chain databases, which are MySQL, Postgres, this and that and all. And then there is this distributed decentralized storage like IPFS, where you would store documentation. And I think what Amit pointed out is the aspect of discussion where we talked about that. Oh, if we have a document with organization one, how the organization two would trust that documentation, and let alone trust how the other organization in the same blockchain network would have access to it. While we are consistently saying that the other organization cannot have access to it because that is not stored on chain, and only thing they share between them is the ledger. So you can say that IPFS in that sense, or Filecoin kind of networks in that sense, are also a decentralized document management system or decentralized storage, which allow you to store files on it and then allow you to access files in a shared way, while the hash of the files, the integrity of the files are maintained. So every time any file is updated, it would be known. And the record of whatever happened on the file is known. Every update is recorded. So yes, the combination of on-chain, off-chain would include IPFS as an ancillary service, which enables the storage of documentation in a distributed or decentralized way, while you would still require off-chain databases for extensive reporting and other implementation purposes. I hope that addresses your point, Amit. And then going to Iqbal next, but I think I'll run through the slides and we'll pick up these questions in the end, because we might end up addressing some of them on their own. So next, we should focus upon, while after deciding which type of chain, which kind of framework, and the kind of design architecture, which includes the data management and data flow of our business workflow, we should come and discuss the integrations which are important for your application. So anytime when we implement blockchain solutions, we never say that we are going to replace existing legacy solutions, because that's a very hard decision for any enterprise to take. So we usually take it from a different perspective. We come and we say like, okay, this is the existing solution, and these are the aspects where transparency may be questioned, or we got trust issues, or we got disputes, and this is the data which is associated with it, and this is part of this XYZ business process. Now, what touch points this process has got? Which system does it touch? What kind of systems that is it part of? So I'll give you an example. So in supply chain, you may have IoT systems come in play. You may have some ERP systems come in play, because ERPs are very extensive and very detailed systems. You don't want to replace them just like that, but you would want to build on top of them. And I think that's where we also touch upon Iqbal Asim's question, where he asks, is there a difference between off-chain on and existing legacy ERP systems? I would say there is no difference. It is just a perception of how you store off-chain data. And like Amit also asked, the existing ERP systems may have an off-chain storage, but the difference is they are the silo systems. So if there are two enterprises being part of the one supply chain solution, one being the distributor, one being the supplier, they may have their own ERP systems, and they may not allow each other to come into their ERP systems and get access to data. In those cases, they would build a common application on blockchain, where they would decide what to be written on chain and what they would keep on their ledger off chain, and what they would keep as part of the decentralized off-chain data sets. And that would include the IPFS documentation as well. And I think we'll, in some slides, in the next slide, would also talk about the interesting aspect of how even the off-chain can be think of in a different way. So integrations are important, and we need to understand, again, taking the whole business process flow in account, we need to understand that what part of this business process flow is usually disputed, and what are the data sets because of which the dispute occurs, and how do you decentralize that data set between multiple organizations contributing to it? Because we discussed in the decision tree that it depends upon multiple factors around the data sets. So we have to design the solution in a way that it caters to the existing integrations so that we don't replace the systems outright, specifically because we cannot. And then we need to understand the existing incumbent systems, pretty much, the CRMs, the BIs, and the elastic reporting tools of those organizations, where data sets are already lying or are already structured in one way. So how do we align and integrate the blockchain layer with it? Of course, blockchain is a ledger. Their existing data is another ledger kind of a system. Blockchain is a decentralized shared ledger between all of them. So how would you integrate them? How would you align them? It may vary use case to use case, but ultimately you would need this, because if a supply chain solution is running within an organization, they would still want the same reports. They would still want same inventory, same records coming out of different toolings of theirs, because that makes them productive. So how would you implement blockchain that it enhances the existing capabilities, not shuts them down, not slows them down? For example, inventory control. With blockchain ledger, you may have certain batching items or SKUs entered into on-chain ledger as well, while some metadata related to it would remain off-chain. So on-chain data would give you better inventory control downstream, upstream, both ways, down the supply chain up to the distributor and retailer. But then the existing metadata on the off-chain system would allow you quick reporting. So it's a mix of both then. But then it gives, it gives birth to next generation of, BI and reporting tools, which are built on top of blockchain and off-chain systems. And then this is where I'll touch upon, the off-chain again one more time, and probably the last time today. The design of these solutions, it has to be with the intent of including blockchain. So because, at this point, we're not discussing if blockchain is a fit or not. That has already been decided. And if that has been decided, you have to keep the intent right, that blockchain should come in the best way possible it can. So now coming back to the same organization A and B and supply chain example, both of them may have their own blockchain database and some other components. But beyond ledger, you can design the solution in the way that even the off-chain components of it can be decentralized and can remain with multiple organizations, because the primary data entry or ingress is happening through the blockchain ledger and then only going into the off-chain ledger. So if the off-chain pieces of data, if they can further be fragmented in a way or segregated in a way that even this bit is to be shared between two organizations, but yet to be stored off-chain because the nature of data is that, then you can design MySQL, Postgres kind of, micro or macro databases within the, blockchain solution bucket and distribute them as well. But make sure that you would never write first in the off-chain ledger. You would always write first in the on-chain ledger, and as an atomic trigger of that, the data should go into the off-chain ledger, both ways. That's very, very important, because once you write into the off-chain ledger, you are actually breaking the principle of trust. You are actually modifying a data which people usually cannot trust, which is the off-chain data. So you must always write on-chain first and then an off-chain, and then you are in fact enabling a possibility where off-chain ledger can also be decentralized with multiple parties. So appropriate decentralization was the call in the last slide. Now, how, this design in itself is a lot. It required a lot of brainstorming in the business flows, existing solutions, integrations, existing tooling, existing solutions, and then on-chain, off-chain, and then batching. It would require a lot of hustle within the organization to get to the point where you decide, okay, fine, we now know everything. We have structured it, we have architected it in the sense of what stores where and how it is shared, when it is shared, what is not shared, and what kind of atomic relation would you want, and what kind of ledgers, what kind of reporting integrations and tooling you've done, and so on. So the point comes to, how do you build it? Now, building a blockchain solution means, of course, pretty much the standard software development, but with some twist. We need to pick protocols like we discussed in the initial slide, the frameworks, the hyperledgers, the R3s of the world, or maybe the private subnets. And when you do so, there is a specifically defined stack which comes with it. There are protocols which are very open nowadays. They're improving every other day. They're coming up with more and more support for different type of architectures and layers. But I'm telling you this because the same stack in which your SAP is programmed in may not be the stack your blockchain solution would be programmed in. But then the most interesting aspect of today's generation of solutions is that they're always built in a microservice architecture. And when that is the case, you always have got APIs to integrate with. So we talked about integrations, the importance of them with legacy systems. But then when you build a solution, you must consider, regardless of what tech stack it is built in a way that it always integrates both ways. And that can happen through generic interfaces of APIs, REST APIs, WebSockets, gRPC interfaces and all, so that you can support your legacy systems the better way while still build the blockchain solutions the blockchain way. So this is one important aspect. Because we are not discussing it thoroughly technically, I'll not go into it, but if you would go to Hyperledger Fabric, you can program your chain codes, the blockchain smart contracts, in Node.js and Golang. If you go R3 Coda path, you've got Java available to you as well. But then, the languages won't matter when you would prefer, integrating different parts of your application and modules using APIs. So they won't matter. Now, beyond this, automation and monitoring is an important capability you would need. So this is part of the whole enterprise design. Uptime in the end is matter a lot for you and for your solution. And because there will be so many integrations in between, and what happens on the ledger is sync state, and those kind of things would be very important, and specifically to meet the regulations and compliances, and to do a lot of proactive handling or incident management and recovery. This would be vital to your solution. So when you architect a solution, when you design a solution for an enterprise, of course, blockchain in itself is very redundant, but then you would also require a lot of monitoring around it. And more the automation based approach you would take, the more beneficial it would be. We talked about it in the last episode where we focus how automation would cut down a lot of cost on your monitoring and management, while you would increase your ROI, because that is what is questioned in enterprise solutions. Now, there are more questions. I think I'll pick them in a while. But this is, this is, of course, specific to, you can say, nothing. This is specific to nothing. This is a very generic, very high-level architecture where you can see that, the distributed ledgers. We talked about different layers, right? The distributed ledger, which is the blockchain ledger layer, it's at the bottom of everything. Then you've got, integrations in between. And this includes plethora of things, whatever you can imagine in today's enterprise ecosystem. There is everything which you have to think of while planning it. But this is, just an idea of where do you put what and how do you consider them. And from the governance perspective, you can see the, color coding of these blocks. You would understand that where and what kind of service or component would be under what category and how do you handle it. This is a very elaborate slide. I'm not sure if we can cover it like, the whole explanatory and descriptive way. But this would give you enough idea of how do you create the construct of the enterprise architecture of yours. And I'll just touch upon a few important points. REST APIs, we talked about it because this is the application facing piece. You don't want a blockchain interface to your application, because that does not exist. The only interface we have seen and we will see would be the mobile and the web interface and the desktop application interfaces, and they fetch their data from somewhere. And that somewhere may be somewhere in your backend, and that backend may be talking to your blockchain, your off-chain ledgers, your IPFS services, and other similar, maybe your BI reporting tools, maybe your clouds, maybe your IoT devices, maybe AI models and all. So it has a very important role to play. But at times, API won't be the only way. You also would require certain SDKs. So those will come in handy. So you may integrate it with your SAP systems, your Microsoft BIs and others, but then you would require a lot of tools and combinations to figure that out. And that may vary use case to use case, industry to industry. But this is how it is usually constructed. So on top there is application, which is user facing, which is the operator facing, which is the consumer facing, where you would not see blockchain just as blockchain is. You would see some hashes, of course, you would see some transaction IDs, of course, but rest of the operation would remain the same, because we are not changing the way supply chain is today. We're simply making it better. We're not changing how trade finance is done today. We're simply enhancing the capacity of it, in terms of time being more time efficient. So similarly, it works for different industries, but we're not changing the business flow completely and not changing it into something else. I'll take a question, I think, on this slide, that how much data size is limited for storing on chain. Also, if there is a specific client requirement that data or file should go on chain, then how that can be handled. So to answer the first part of this question, how much can you store on chain? It totally depends upon the kind of protocol are you using, and what block size does it have, and how many transactions you can pack in each block. But then I still would tell you that you may not be able to store more than a few kilobytes per block, which means kilobyte is like a lot. I would say like you would not be able to store kilobyte. I would say some 30-40 kilobytes is the ideal payload you would plan, or maybe up to maybe sometimes up to a few MBs, but not more than that. And then to answer the other part of the question, that how would you handle to such a client requirement where these kind of things or files should go on chain. So that requirement is not that the file should go on chain. The requirements usually which we will be facing when we'll be dealing with enterprise customers, it will be that I would want a provenance of this file, its validation, its proof of existence, that this file is never touched the way it was generated. It is sacrosanct in the sense that regardless of which parties it has traveled to, everybody can trust it the same way. So again, you keep the file off chain, but when you are generating the file the first time, you generate a hash with it. You store the hash against the generation transaction onto the ledger on chain. And every time you need to validate the file's existence, you take the sum, checksum out of it, the hash out of it, and you match it with the hash you have stored or the checksum you have stored on chain at the time of the transaction. And every time the file is supposed to be edited or modified or updated, you repeat the same process. So it would enable you and the customer to gain trust in the, or maybe the whole staking, also just not staking, the whole stakeholder ecosystem gain trust in the file's provenance and its existence and operations done upon it, because they can always be proven in a reverse way from the on-chain ledger. I hope that answers your question. Now, so Iqbal has got so many questions. So Iqbal is asking about, with so many tech companies promoting their own blockchain solutions, this is an interesting one though. How can enterprise differentiate which is the right solution for them? So, I have my own opinion about this that may not be completely right, but I would, mention it. So enterprises are mostly, driven and challenged in terms of, if they can adopt the technology or not by compliances and regulations, and their own internal compliances at most. So they always have to go ahead with a protocol which meets their internal compliances a lot or get very close to it. So for example, I would say that open source is becoming the new compliance, because, you're not worried about the scrutiny or the screening of the application which is being given to you as a black box, because you can see the code your team can screen, and then you're not worried about the business continuity risk because you can keep it forever with you. And if that is the case, you're handling some of the major compliances internally. But then there is a lot more around it too. So when picking a protocol, always focus upon what meets your compliances the most. The rest of the compliances will be given or solved by blockchain as a service platform, infrastructure as a service platform, because they decide or help in deciding how it is run the best way for your compliances. So yeah, just pick what is meeting your compliance requirements the best, and then get working with the players who are making it further easier to adopt to it. And any enterprise blockchain adoption with which Zeeve was involved, and the problem, the solution. So a case study, I'll try to answer it in the end. It's a long one, so I'll try to answer it in the end. But yes, definitely, we've been part of such implementations, and I would love to talk. And this is a slide where I would not focus much because we've got less time available to us. But then there is a myth and there is clarity to it as well. The blockchain network challenges business. This is as per me. It may not be as per you or some folks out there, but the challenge is not tech, it's business. Because business business challenges are, like Iqbal said, they start with compliances themselves, the ROI challenges, the governance challenges, the continuity risks, and the cooperation between multiple parties coming together, and specifically the competitors. This is still a challenge in the business world, which is stopping the adoption to happen. And even if you bring parties together, how do you build trust? And if you have built trust, then how do you further scale it with newer and newer people? Because you'll have to continue to establish trust that way. Of course, there are technology challenges, and we're not denying that, like interoperability, still talked about a lot, but there are no solutions to it yet in a complete way. There are solutions which are coming up. We talked about private subnet side chains. We talked about hybrid blockchains. So things are happening. They're happening fast. And I think in a conclusive way, we can say that technology would not be a roadblocker. And if we would, summarize the challenges in some way, you can say that, the competitors, they are still not getting it, how to get to cohesion and a beneficial cohesion, a collaborative cohesion in the end. And then, of course, when parties are multi and they are themselves enterprises, doing different type of or part of business workflow, how do you maintain governance? And then who's going to be owning what cost in the whole consortium should also be a question. And there are other challenges too, like committing to a network. Is there a way back into the old system? If you are committed to a system once, can you go back? Can you actually opt to the old generation of the system again if something goes wrong? So that insecurity still exists. And then there are 4 approaches which can mitigate this risk, but still there is a lot of ground to cover, in the sense that the trust, the cohesion would come in play. So of course, MVPs, that's the way for enterprises. They have to go through designing small viable products and projects, and then test them out with simulated data, and then some real time data in some limited environment. So to gain more understanding around what would happen to their processes, how and which section of the process would be improvised and modified and would get benefited. And then of course, governance, it cannot happen in day zero. It should take its own course, and then should fall into the right structure and right incentive model for all the participants in the ecosystem. These are 2 of the main fundamentals which should be taken care of. Rest technology challenges are solved faster than we can imagine. This is the last slide of the day. With it close, this shows you a roadmap. If you would want to adopt it within your organization, how would you do it? You would start with a use case, like I said, reach up to a POC, a proof of concept, which is based on what challenges are you having, how best you think blockchain can solve based upon a lot of inputs. And then what do you prioritize? The visibility, the feasibility, and the business alignments. And once you reach a proof of concept, you attempt to build a ecosystem around it, where you would develop technical architectures, functional designs. You would involve blockchain technology, get to the stage where we talked about you actually start building it. So by this time, when we say designing functional and technical architectures, we mean on-chain, off-chain, everything should be sorted. And that's what takes you into the typical implementation and prove and build and test, and prove and build and test kind of iterative environment. And once that is done, take a look back, learn from whatever happened through your use case while the proof of concept was done, what kind of challenges you saw, or you seek to solve, were they solved or not, and what benefits were generated, where the process went slow, where the process went better and improved, and then plan to scale. If you think from that point onward, blockchain actually worked out for your solution or your enterprise solution, then just plan to scale with right governance and right consortium building. And that includes a pilot with real-time data beyond just simulated data. And then you have to institutionalize the operating structure, then you'll have to, engage the regulator, the compliance players, so that, it is done right and it is adopted well. So this is, a typical roadmap which one can follow to, attempt something within their organizations. And we are just a call away. Here I can, time is already, beyond what was scheduled, but I can quickly talk about, a couple of use cases. So we have worked with one of the largest, European telcos for, one of the blockchain implementations of theirs. Of course, we are not a consulting company. We are the automation company, which, fills in the gaps in the architecture in terms of how the network would run, how it would optimize, it would become more cost efficient for, an enterprise to maintain and scale. Scaling is the most important aspect of our solution, and how the whole building part, the SDK implementation, the developer part, the smart contract development part would come into the play. So this is what we do. So our use case is usually not implementing the business workflow. That is to be done by the enterprise with some software vendors. We don't jump in there, but once they are doing it, how to make it manageable, monitorable, automated, and also scalable is our job. So we've done, several use cases because we are use case agnostic, and we've done with some Fortune 500 companies as well. And the examples I talked about, some of the companies are running those businesses today using Zeeve and scaling faster. You can always reach out to us, for advices and opinions and expert opinions as well. And we exist everywhere. So so the next session, you would get to know about it pretty quick. And again, I'll repeat that first was about the cost of doing blockchain. You can find the recordings of it on YouTube and all. And then today's was about the design of a blockchain solution. And I think you'll soon get to know that the series would continue, and we'll see you in the next sessions as well. I'll answer some of the questions. I think the only question which remains is, can we get the deck of both the episodes? Yes, of course. They'll be provided, they'll be uploaded, and we'll continue to do more sessions with GBA, specifically focused on enterprise blockchains. Thank you for your time. Thank you for all the questions and participation. Let's keep discussing enterprise blockchains. Let's make the adoption faster, better, and let's build better Web3. There's one more question from Ravi Vishwas. Beside the deck, can we get a copy of the recording? Yes, of course. I believe, we'll also provide a copy of the recording. No problems there. So I think sooner or later we'll upload those links and then they'll be available. Where we can see the decks uploaded. I think they'll be uploaded on the GBA sessions, and we'll also publish them through different social media channels. If you're following, if you've signed up through this webinar through one of those channels, you would see the recording and the deck updates are available to those channels itself. Right. So yeah, I'm still here. In case you've got a couple of questions, I can answer them, or I would say good night to some people and have a wonderful day to some more, because this is a different time in different part of the world as of now. So thank you very much, and see you in the next session. Yeah, but I think I'll definitely try to cover some real use cases in the next coming up sessions. I'll figure out slots for these. Thank you, Mike. Yeah. Thank you, everyone. Bye-bye. See you soon.